Yes, Assalamu alaikum. This is 970952 Mathematics Paper 5 Probability and Statistics 1 February March 2023 solution. So the first question is that each year the total number of hours X of sunshine in Kintu is recorded during the month of June. The results for the last 60 years are summarized in the table. Uh, in the table we have X ranging from greater than or equal to 30 less than 60 and greater than or equal to 60 less than 90. We have the corresponding frequencies there. Draw the cumulative frequency graph to illustrate the data. So as you know that for the cumulative frequency, we plot the cumulative frequency against the upper class boundaries. So we need to identify the upper class boundary and the cumulative frequency. So upper class boundary. So if you notice that the first class is ending at 760 and the next starting right from 60. So yes, these are the class boundaries. So upper class boundary is 60 for the first. So upper class boundary is, you can write less than 60, less than 90, less than 110, less than 140, less than 180, less than or equals to 240. So these are the upper class boundaries and CF, cumulative frequency. So we cumulate the frequency. The first is 4 and 4 added to the next frequency. 4 plus 8 is 12, 12 plus 14 is 26, 26 plus next category, next frequency is 20, is 51 and is 51. 51 plus 7 is 58, 58 plus 2 60 years, there were 60 years. And the lower class boundary of the first class is 60. So if we just write for the understanding, how many readings are less than 30? So what is the frequency less than 30? Nothing, 0. So here, after after finding the cumulative frequency and the upper class boundary, now what you can do on the graph, you can take the cumulative frequency on the vertical axis, the cumulative frequency on the vertical axis, and less than 30 is 0. So you can take the cumulative frequency on the vertical axis. So here is the cumulative frequency. And on the horizontal axis, take the time. So you can say the total number of hours. So here I can write the number of hours. So next we'll be plotting the values. 60 is 4. Is 60, the value is 4. If it is 90, the cumulative frequency is 12. You can notice here, already we have the graph here. For 60, it is 12. And for the next 110, it is 26. For 140, it is 51. So in this way, it is 51 here. In this way, you can plot the points, the cumulative frequency against the upper class boundary. So I'm using 51. I'm plotting 51 against 140, 58, 180, and for 240, it is 60. So in this way, we have I plot the points, and after plotting the points, you can join them with a smooth curve, and this graph is called the cumulative frequency graph or the cumulative frequency curve. So by plotting the points here, we have the values, different values are there. So there are 1, 2, 3, 4, 5, 6. So 6 points you can plot. And finally, uh, don't forget to join with the horizontal axis because nothing is before 30. So don't forget to draw this part. Don't leave it, start the graph right from a 4. So you'll need to end always join with the horizontal axis. So this is the complete cumulative frequency graph. Simple. So keep in mind that cumulative frequency on the vertical axis and the number of hours on the horizontal axis. In this way, we plot the points, and the basic thing, cumulative frequency against upper class boundaries. So need to identify the upper class boundaries. So upper class boundaries were again, just for understanding, so upper class boundaries were 60, then 90, 110, and 40. Why a boundary? Because it's same as the first number of the next class. So 180 is the upper class boundary, 240 is the upper class boundary. So this is how you can draw this cumulative frequency graph. Next part is use the graph to estimate the 70th percentile. So 70th percentile, so 60. So 60 is the total number of years, 60. So find the 70th percentile. So 70th percentile means 70% of 60 number of years is 70% of 60, and 70% with the calculator, 70% of 60 is 42. So 42, this is not the percentile, but the value against this will be the, so 42 is here. So draw for 42, draw the horizontal line, and after joining to the graph, move towards the horizontal axis, move towards the horizontal axis. So we are here somewhere. So use the ruler for this working. So when we reach here, this value which we are obtaining, so this is the value corresponding to, this is the value corresponding to 40. So this answer, this value which you are, number which you are obtaining here, the reading over here is 120. So one small block is equals to 4 in this, for this graph. So I started from 0 to 40 and then 80, so on. You can take a different scale. So this value is 126. 126. So the 70th percentile is 126. So the value which we read against 42, this is the 70th percentile. This value is the 70th percentile. Next. So we have the graph, cumulative frequency graph, and with the help of cumulative frequency graph, I found the 70th percentile of the data. 42, the reading against 42 is 126, and 126 is the 70th percentile. The next is calculate the estimate for the mean of mean number of hours of the sunshine in Gintu during June over the last 60 years. So we know the formula for the mean. X bar is sigma fx over. So I'm using capital letter because already there is small x in the table. So fx. So what is x in this case? So x is the mid value. So the mid value I'm using as x. The formula is simple, sigma fx over sigma f. So next you can find the mid value for the classes. For 32, for 60, the mid value 30 plus 60 divided by 30 plus 60 divided by 2 is the mid value. So 45 is the mid value for the first. 60 plus 90 over 2 is 75. Then is 100, the mid value of 90 and 110. Next is 125. 110 plus 140 divided by 2. Then is 160, the mid value of 140 and 180, and 210. is the mid value. Next, for the formula, sigma fx over sigma f. So from here, sigma f you can find, this is actually the total number of years, 60. So you can add 4 plus 8 plus 14, 25, 7 and 2. So the answer is 60. And yes, we need fx. Fx means multiply the two entries 4 and 45. 4, 45, 45, 4, so 180. The next is 75 multiplied by 8 is 600. 100 multiplied by 14 is 1400. Next is 125 multiplied by 25 is 3125. Next is 160 multiplied by 7 is 1120, and 210 multiplied by 2 is 420. So sigma fx you can find when you add all these values, we have sigma fx, and you can add. So the answer you can verify 6845. 6845 is the sigma fx. So mean is sigma fx over sigma f. So use the values which we have obtained from the table. 6845 divided by 60. So the answer is coming as 6845 divided by 60 is 114.0833 dot dot dot. So answer we write to three significant figures. So the mean is 114. So the mean value is coming as 114 is the mean for this question. So mean is 114. For the next question with 2, Aisha has 4 coins. One of these coins is biased, so the probability of obtaining the head is 0.6 biased. So the probability of head on the biased coin is 0.6, and the probability of tail on the biased coin is so different probability. So the other is fair. So I'm writing F for fair, B for biased. So probability of head on the fair coin, if it is fair, obviously 0.5 is for the head and the tail is again 0.5. So the other 3 coins are fair. Alicia throws the 4 coins at the same time. The random variable capital X denotes the number of heads obtained. So X is for the number of heads. Show that the probability of obtaining exactly one head is 0.225. Probability of exactly one head means probability of X is equals to 1. So as there are 4 coins and one is biased, the other 3 are fair. So what are different possibilities? So we need to identify the different possibilities. So there are 2 categories, biased and the fair. So what I can do here, probability of head on the biased coin and head on the biased coin. So I can write S H and T in the, so head on the biased and tail and tail on the fair. Or the other possibility is no tail on the tail on the biased and one head on fair. So one head on fair. One head on the fair. So one head on the fair means head and the rest are tail. So one important thing which we must notice here that head and tail can be in any order. It can be head, tail, tail. It can be tail, head and tail. It can be tail, tail and then head. So we need to cover all the cases here for the second. So first is head on the biased 0.6 and means multiplication and tail. So 0.5 multiplied by 0.5 multiplied by 0.5 power 3. Okay. Or tail on the biased means 0.4 and multiplication one head on the fair. So one head on the fair. So I have listed one of the possibility head, tail, and then tail. So head is 0.5. Tail is again 0.5. There are two tails. I can write 0.5 power 2. I can treat this question as a binomial, the second part, but it's simple to handle like this. So as stated earlier that for one head on the fair, its head can be at any position, first, second, or third. So we need to recall the basic concept of the permutation combination that head, tail, tail can be arranged in how many ways? This can be arranged in 3 factorial divided by 2 factorial ways. So instead of writing head, tail, tail, and then probability of tail, tail, head, and the third possibility in this way. So why not to just write 3 factorial over 2 factorial? In this way, you can cover everything. So simplifying. So let us simplify the first. So it is 0.6, 0.6 multiplied by 0.5 raised to the power 3. So this is coming as 0, 0.075, and the next is 0.4 multiplied by 3 multiplied by 0.5 multiplied by 0.5 power 2. It is 0.15. 0.15 added to 0.075 is 0.22, and yes, we want to do the same thing. So probability of one head is 0.225. 0.22 and 5. The second is complete the following probability distribution for X. So there are two blanks here filled. So you can find one, and the rest you can find by subtracting the sum of the rest of the probability from one. So here let's find for anything like for X equals to 3. What's the probability that there are 3 heads? There are 3 heads. So 3 heads means that probability so there were 2 categories, biased and the fair. So head on the biased and one head from the fair, or or tail on the biased and P heads on the fair, because they want to obtain 3 heads. So these are the possibilities. Again, one head means one head and the rest are tail. Here, all 3 are heads. So in this way, you can write the answer like this. Head on the biased is 0.6 multiplied by head, tail, tail. For head, one biased, and I'm looking for, sorry, 3. I'm looking for 2 heads here, because overall 3. 2 heads means head, head, and tail. So 2 heads means 0.5 raised to the power 2 and 0.5, and further these can be rearranged in many ways, like 3 factorial as it did earlier. Plus the other option is tail on the bias means 0.4 multiplied by 3 heads means head, head, and head. 3 head means 0.5 multiplied by, on the fair, 0.5 into 0.5 power 3. So you can involve the binomial distribution here, but simple to handle like this. So when you simplify, the first is 0.6 multiplied by 3 multiplied by 5 raised to power 3, 0.225, 0.225 plus 0.05 added to 0.225. So the answer is 0.275, 0.275. So this entry is 0.275, and you don't need to do the working for the remaining for x equals to 2. Therefore, probability of x equals to 2 is 1 minus the sum of the rest, 0.05 plus 0.225, this value, plus 0.275. The sum of probability is always equal to 1, 0.75. So when you simplify, it is 0.375, 0.375. So we have the answer to this part. The last part is, given that expected value of x is equals to 2.1, find the value of variance of x. So the formula for the variance of x is sigma x square p minus expected value of x square. Expected value is already given. We just need to multiply x square by p, but x square is not there. Yes, you can make a column for x square. X square is here. So x square. X square is 0, 1, then is 4, then is 9, then is 16. So x square multiplied by, so multiply these two entries, x square multiplied by p, and then sum. So in this way, x square p is, so variance of x is x square p. Multiply the corresponding x square by p, 0 multiply by p. The first is 0, second is the 1 should be multiplied by 0.225. The next is 4. 4 is multiplied by 0.375 is 0.375 plus 9 is multiplied by 0.275, 0.275, then 16 is multiplied by 0.075, 0.075. So this is x square p minus expected value of x, which is given as 2.1 square. So simplify, the inside the bracket is 0.225 plus 4 into 0.375 plus 9 into 0.275 plus 16 into 0.075. So 5.4 for this bracket minus 2.1 square is 4.41. So 5.4 minus 4.41 is 0.99 is the variance of x, the answer to this part. .99 is the variance. Well, question number 3. 80% of the residents of Kinwawa are in favor of leisure center being built in the town. 20 residents of Kinwawa were chosen at random and asked in turn whether they are in favor of leisure center. Find the probability that more than 17 of these residents are in favor of the leisure center. So 80%. So it's talking about the layer thing. So layer is here. So in favor of the layer. So what's the probability of the so I can use P for this is equals to 0.8 is the probability of layer. So for this question, I can take P is equals to is the probability of the layer. So probability of success, P is equals to 0.8, then Q will be 0.2. This is a question on binomial distribution because 20 residents are chosen at random. So there are fixed number of tiles, 20 residents are chosen at random. So this question is of binomial distribution and he's talking about the layer thing. So binomial distribution, I can use X, the variable, discrete and so X has the binomial distribution with 20 residents means 20 trials and 0.8 is the probability of success. So here I can write like this. Probability of the layer center. So N for this question is 20. P for this question is 0.8. Q for this question is 0.2. Find the probability that more than 17 of these residents, more than 17 of these out of 20, more than 17. Probability of X more than 17 are in favor of the leisure center. So this is the question. Probability of X more than 17 means probability of X is equals to 18 or 19 or 20. So you recall the formula for the binomial 20. So formula is probability of X is equals to R is equals to NCR PR Qn minus R. So here 20, 18 PR. P is 0.8. R is the bottom number. So this R is here. So this R, this number is the power of P. So PR and Q n minus R 20 minus 18 2 plus or means plus 20 C19 point, so 0.8 raised to power 19 and 0.2 raised to the power 1. So lastly 20 C20 PR and Q power n minus R, which is 0. So when you simplify 20C 18.8 to power 18, 0.2 to power 2, 0 point, so the answer is 0.13691. 13691 plus 20C 19.8 to power 19, 0.2 to power 1. So when you simplify, it is 0.05765. The last 20C 20, which is 1, and 0.8 to power the 20 is 0.01153. Adding these values, 0.13691 765 plus 0.01153. So the answer is 0.20609, and as we write the answer to C significant figure 206. So probability of X greater than 17 is 0.206. So this was question on binomial distribution. So there were fixed number of trials, 20. The probability was constant. The probability of the layer club is constant, 0.8. So in this way, you can handle this question based on the binomial distribution. Second part is the probability that the fifth person asked is the first person who is not in favor of the layer club. Find the probability that the fifth person are the fifth person. So you can do this by listing that there are is the fifth the first is not in favor, so is not in the first is in the favor. So there are two different methods. Probability of the first person who is in the favor of the layer center. The fifth, and that person is the fifth. So it means that which is not in the favor. So probability of favor we have from the above statement is 0.8 and probability of not in favor is 0.2. So here the success is not in favor. So means favor, 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 and favor, and the fifth person is not in favor. And the fifth person is not in favor. So favor means 0.8 into 0.8 into 0.8 into 0.8 power 4, and not in favor 0.2. This is one way of doing this question, and you multiply, the answer is there. 0.8 raised to the power 4 multiplied by 0.2 is 0.08192. 0.08192, 0.0819, correct to three significant figures. So you can also solve this question by using the geometric distribution. For the geometric distribution, what I can do, x follow the geometric distribution, and here the probability of success is not in favor, so you can write 0.2. So P is equals to 0.2 for this case, part B, and Q for this part is 0.8, because the important thing to notice is that he's talking about not in favor. Not in favor is the success. So what you can do, recall the formula that for the geometric distribution, if P is the probability of success, the probability of x equals to r was, the formula is q to power, first there are failures. How many failures? R minus 1 failures, and there is a success. So this is the formula for the geometric distribution. Now here P is equal to 0. So probability x is equals to 5. So x equals to 5 is q raised to the power 5 minus 1, which is 4, and P. So Q is 0.8 raised to the power 4 and 0.2. This is O. So you can do it directly, or it's better to apply the geometric distribution, and we need to know what is the success for this. So success is not in favor of the club, leisure center. So P is 0.2 and Q is 0.8, and the fifth person asked is the first person who is not in the favor. So in this way you can manage the situation, and answer is same, 0.8 to power 4 and 0.2 multiply 0.0819. 0.0819 is the answer. 0.0819. Both methods are valid. Third part is find the probability that the seventh person asked is the second person who is not in the favor of the club. So again, there are two methods for solving this question. Find the probability that the seventh person asked is the second person in that, which is not in the favor of the club. So this is basically, I can write that first not in favor, then 1, 2, you can write many here, 1, 2, 3, 4, 5, and The seventh person is not. So this is the seventh. So you can manage like this. And next I will solve this question in a different by using the binomial. So this is the seventh. You can count them 1, 2, 3, 4, 5, 6, 7. Further, these can be rearranged in many ways because the first person, it can be first position, second, third, fourth, or fifth, or sixth position. So what I can do for this question, I can say that not in the favor is 0.2, and then in the favor there are 1, 2, 3, 4, 5. So I can write 0.8 raised to the power 5, 0.8 raised to the power 5, and as these can be, there are 6 things and there are similar things there. So what I can do, so as I did earlier, so there are 6 things. I can write 6 factorial divided by 5 because layer, there are 5 things there, common thing, multiplied by not in the favor of layer 0.2. This is one way of doing this question. The other is that the probability that the seventh person asked is the second person who is not, or the first 6 things can be managed by using the binomial. There are 6 trials and the probability of not in the favor is 0.2, and here I can I can say that n is equals to 6 and p is equals to 0.2 and q is equals to 0.8, and the probability that the seventh person asked is the second person. So there is one person before and the seventh is the second. So I can do it like this, that first out of 6, so this is the required probability. This is the required probability I'm obtaining for this part. The required probability is, so 1 out of 6 not in the favor in the first group, power PR and Q n minus R, and the seventh person 0. This is actually the seventh person. When you simplify, 6C1 is 6, 0.2, 0.8 raised to power 5 multiplied by 0.2. So this is same as before, because 6 factorial 5 factorial is 6, 0.2, 0.8 to power 5 and 0.2 the seventh person. The same, but using a different technique, using the binomial distribution. Okay, for the first 6 persons, you can use the binomial distribution, and the seventh person is 0.2. So 6 multiplied by 0.2 multiplied by 0.8 raised to the power 5 multiplied by 0.2. Yes, this answer is coming as 0.0786. And yes, simplify this answer, write this answer to 3 significant 0.786. So this is the required probability. So the important thing is to understand the statement. So find the seventh person asked is the second person in that order. So it means that in the first group of 6, there is one person who is not in the favor of a leisure club, and the seventh person is the person in that order, the second, and that is the second person, second person in that order. The seventh person, so first there are in the first group of six, there is one who is not in the favor, and the seventh person is again not in, and obviously this is the second. If you just count L dash, L, and then L dash, so there are two in that order, and the seventh person is not in the favor. So this is how you can manage the situation for question number 3. Question number 4 is, okay, the probability that it will rain on any day is X. If it is raining, the probability that Aaron wears a hat is 0.8, and if it is not raining, the probability that he wears a hat is 0.3. Whether it is raining or not, if Aaron wears a hat, the probability that he wears a scarf is 0.4. If he does not wear a hat, the probability that he wears the scarf is 0.1. The probability that on a randomly chosen day, if it is not raining and Aaron is not wearing a hat or scarf, is 0.36. Find the value of X. So you can do this directly, but the tree diagram is always helpful. So the important thing here is that the probability that randomly chosen day is not, that on a randomly chosen day, it is not raining. It is not raining. So find the value of X, that Aaron is not wearing a hat or scarf is 0.6. Find the value of X. What is X? X is the probability that it will rain on any given day. So you can do this directly if you just make links, but connect the situation there. But better is to draw the tree diagram just to clear the concepts. So there are two categories: raining, not raining. So he's talking about the situation, the last underlying thing, that not raining. So you don't need to complete the upper part, just focus on the not raining. Start from the not raining. If it's not raining, then there are two possibilities: hat, no hat. So H for hat. So it is raining or not. So probability is just focus here. If it is not raining, the probability that wears hat is 0.3. So the probability of raining is X. The probability of not raining is 1 minus X. Probability of hat, if it is not raining, is 0.3, 0.3, and 0.7. And next, whether it is raining or not, if Aaron wears a hat, the probability with a scarf is 0.4. Scarf, no scarf. So scarf is 0.1. Sorry, not 0.1. 0.4. 0.4. And obviously this is 0. The sum should be. So yes, you can complete the rest of the tree, but if we just focus here, that the probability that randomly chosen day, if it is not raining, Aaron is not wearing a hat. Okay, now we should move further here, here and here. Scarf, no scarf. 0.1 as mentioned. If it does not wear hat, the probability scarf is 0.1 and no scarf is 0.9. Now just look at the last statement with a different highlighter. The probability randomly chosen day not raining and not wearing hat, not raining, not wearing hat or scarf Yes, this probability is 0.36. So what you can do, 1 minus x, so using the condition, using the condition in the question, 1 minus x, 0 plus 7, 0 plus, sorry, 1 minus x, 0 0.7, 0 0.9 is equals to 0.36. So you can simplify 0.36 divided by 0.7 divided by 0.9. I can do it directly. It is 4 over 7 on the right hand side. 1 minus x is equals to 4 over 7. So x is equals to 1 minus 4 over 7. 1 minus 4 over 7 is 3 over 7. So this is the answer. Question was to find the value of x. So x exact value is 3 over 7. A simple question. So you don't need to complete the other link like for the raining because the last statement was regarding the not rainy day. So a simple question of probability. Question of 5. Important question. Marco has 4 boxes labeled K, L, M, N. He places them in a straight line in the order K, L, M, and N with K on the left. With K on the left. With K on the left. K, L, M, N. Marco also has 4 color marbles, red, green, one white, and one yellow. So these are the boxes and the now question is he places a single marble in each box at random. Event A and B are defined as follows. A. The white marble is in either box L or M. The white is either in L or M. So there are 4 boxes. So probability of A can be probability if it is in L with the probability 1 over 4. If it is in M with the probability 1 over 4. So answer is 2 over 4 is equals to 1 over 2. So either in L, so probability of there are 4 boxes. There are 4 boxes K, L, M, N here on the left. So what's the probability that the box is in L? It is 1 over 4. And what's the probability that is in the other 1 over 4 again? So the probability of A is 1 over 2. The probability of B. The red marble is to the left. The red marble is to the left of both. The red marble is to the left of both green and yellow. Green and yellow. Now, for this probability, the red marble is to the left. So I can, so there are different, so you can use involved permutation combination, but I think better to list. So working for the second part is here. Let me use space is enough. R, G, W, yellow. RG, WY, then R. The question is that red marble is to the left of both green and yellow. Green and yellow. Different possibilities. R, G, W, I, R, Y, G, W. Next. R, W, G, Y, R, W, Y, G. Then W, R, G, Y, and W, R. So in each case, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possibilities here. So these 8 possibilities are there. So the probability that the red marble is to the left. So if there are 4 things, how many ways you can arrange the 4 things? So the probability of B is equals to, there are 4 things, 4 factorial. Probability के लिए we write the total outcomes and there are 8 in our favor. The probability of B is equals to 8 over 24 and the probability of B is equals to 1 over 3. Probability is 1 over 3. The next is determine so condition for the independent event is probability of A intersection B is equals to probability of A multiplied by probability of B. So let us find the common thing. So red marble is to the left and white marble is in either. So you'll have to identify the cases where both conditions are satisfied. The white marble is either in L or M, and the red marble is to the left. So out of these cases, identify the cases when the red marble when the white marble is either in L or in M. The red white marble is either. So this is the case. So KLMN. ऐसे इसको लिखा था KLMN. KLMN. So white marble LM. White marble is here. Yes, this is the case for the common thing. So this case is there. This case is there. No. So white marble LM. LM. Y should be here. This case, yes. So there are 4 cases which is common to both. So in these 4 cases, you can say that the white marble is either in L or in M box, and in these 4 cases, the second is also true that the red marble is to the left of both green and the yellow. So probability of the common thing. तो यहाँ से it was 8 divided by 4 factorial, 8 divided by 24, so 1 over 3. Now I'm looking for probability of A in section B, the common thing. There are 4 common things out of how many? Out of 4 factorial, 4 over 24, 1 over 6. So you need to find the probability of A, probability of B, and the probability of the common. Probability of A and B, the probability of those options, of those links which are satisfying both A and B. A was that white is in either L or M, and the second is that red should be on the left of green. And so these were the cases in which red is on the left of green or the yellow marble, and out of these 8 cases, 4 are satisfying the first. So 4 out of 4 factorial, 4 factorial means the 4 things can be arranged in 4 factorial ways, 1 over 6. So let us check whether this condition is true or not for this. So probability of A multiplied by probability of B. So probability of A multiplied by probability of B is 1 over 2 multiplied by 1 over 3, which is equal to 1 over 6, and yes, it is 1, so which is same as probability of A in section B. So I can say that finally the probability of A intersection B is probability, because the product of these two probabilities is equal to probability of A intersection B, and so we have the solution or the answer. If this condition is true, hence you can write finally that the events are independent. So the question was whether or not even events A and B are independent. So you can say finally that events A and B are independent. Now, next question is 8. Sixth question, this uh, in a cycling event, the time taken to complete a course are modeled by normal. So this is normal distribution question. So for the binomial, for the geometric, so we need to think of whether it is binomial or geometric. But for the normal, the situation would be quite clear, because the question is category mentioned that it is normal distribution. So there's no doubt about it. It's a question of normal distribution with mean as 62.3 and the standard deviation 84 points. So 8.4 minutes. Find the probability that randomly chosen cyclist has a time less than 74. So simple. So in this case, mean is given. So the mean is so normal distribution question. Well, question number 6. In a cycling event, the time taken to complete the course are modeled by the normal distribution with mean 62.3 minutes and the standard deviation of 8.4. So the mean is 62.3, standard deviation is 8.4. Find the probability that a randomly chosen cyclist has a time less than. So probability of x less than 74 minutes. So we need to standardize it first. Z less than 74 minus mu over sigma is the formula. Probability of z less than 74 minus mu 62.3 over sigma 8.4. So this gives you 74 minus 62.3 divided by 8.4 is z less than 1.393, and by using the table, so area up to 1.392, so 1.393, 1.39, so z value is given, so this is called the z value. 1.393 is called the z value. 1.39, 1.39 and 3. So 1.39 is 0.9177 and add 5 here. So 2, actually 0.0005 we are adding. So the shortcut that we just write 5 on the rightmost side. So 5 plus 7 is 12, then 8, then 1, then 9, then 0.9182, 0.9182, 0.9182, 0.9182, and 0.9182. For the final thing, we write answer to 3 significant figures. So probability of x less than 74 is 0.918. The answer, simple, 6 part A. Find the probability that 4 randomly chosen cyclists all have times between 50 and 70. So first we need to find the probability that the time is between 50 and 74. So we need to standardize it first. 50 minus mu over sigma. We have 62.8 over 8.4 less than z less than 74 minus 62.8 over 8.4. So simplifying is equal to p minus 1.464 less than z less than 1.393. So there are, so in this case, so as it is in between, there are two, either you get it from the diagram or there's a shortcut that phi of 1.393 minus phi minus 1.464. So this important result which we use here, that is that phi, whenever there's a negative value, write this as 1 minus phi of a. This is basic result, and the idea is coming from here that if the negative value is there, minus a, So less than this is phi of minus a. So the greater would be same as this because of the symmetry. This is 1 minus phi of a. So you can use this formula for the negative values because negative values you can't read to the table. So phi 1.393 is okay. Negative value you can write further using this result 1 minus phi. So without getting help from the diagram, that bell-shaped diagram, you can manage the situation like this. So open the brackets, phi, this is purely algebraic style, plus phi of 1.464, simply keep this rule in your mind. So from here, use the table 1.393 already calculated, it was 0.9182. It was 0.9182. 0.9182 minus 1 plus 1.464. 1.4 under 6, 1.4, 1.46, it was 1.464. 464 के नीचे is so 0.92, 0.9279 and 6 here is 5.8290 0.9285 0.9285 0.9285 0.9285. Simplify 0.9182 minus 1 plus 0.9285 is 0.8467. So this is the probability 50 is less than x less than 74. So the question was that find the probability that 4 randomly chosen cyclists all have the times between this and this. All have the times. The first is with this time and the second and the third and the fourth. So the required probability, find the probability. This is a probability from 50 to 74. So probability that all have times between all 4 have times between 50 and 74 means multiply is equal to 0.8467 raised to the power 4. Raised to the power 4. So the answer is 0.51396. 5139 so on, and we write the answer 0.514 is the answer to this part. So all 4 means the first of this category 0.5467 and the second of the same category 5467 and the third of the same category 5467 and the last one they are 4 cyclists 5467. So this is simply raised to the power 4, and so we have the answer to this part. All 4 have the times between this and this. Now part C, In a different cycling event, the times can also be modeled by a normal distribution. 23% of the cyclists have times less than 36 minutes, and 10% of the cyclists have times greater than 54 minutes. Find the estimates of the mean and the standard deviation for this distribution. Now, for this question, the information given is that 23% of the cyclists have the times less than 36 minutes. The probability of x less than 36 minutes is 0.23, and 10% of the cyclists have the times greater than 54 minutes. So probability of x greater than 54 is equals to 0.110%. So find mean and the standard deviation. Mu is question mark and sigma is question mark. Mu is question mark and sigma is question mark. So first we need to standardize. Probability of z less than 36 minus mu over sigma is equal to 0.23. For the convenience, what you can do, you can let this 36 minus mu over sigma as a. If this is a, then probability of z less than a is equals to 0.23. So less than means phi a is equals to 0.23, and in this case, this is called the z value and this is p. So here p is given. So p is given means that table, in the table z is here. So z value, so, and this whole spread of the numbers is p's. So here try to find value of p is equals to 0.2. This is p. This is p. This is p. Find 0.23 here in the table. So 0.23 is not here. The smallest value which you can find here is 0.5. So 0.5 is the smallest value of p, which you can find the table, but 0.23 is not there. So if 0.23 is not there, so you can apply basic algebra and basic concept, basic logic you can apply, that I want to make the number on the right hand side is greater than 0.5. So what I can do this basic algebra, 1 minus phi of a and 1 minus 2.23. So the right hand side is 0.77, and here, as I explained earlier, this is phi of minus a. So p, this value is p is 0.77, and for this we'll read the table in the reverse. So in the reverse 0.77. So 0.77 I think is not here. So the 0.77 is not here, but yes, this is number greater than, but the number which is immediately less than that is 0.7673, but we need 0.77, so something should be added here so that then it will become 0.77. So what should be added in the last two digits to make it 0.77? So 0.7673 is 0.73. So simple, if you add 27 on the right side, we can make it 0.77. So simple, if you write 27 here. So how to know what number should be added? So technique is simple. So like if it is 0.77, so you just make 4 digits by removing the decimals, and 7673. When you subtract, we have 27. So in this way, you can know what should be added in the last two, 27. And let us find 27. Yes, it is there, and this is below 9. So it means that 0.7700 you can make by adding 27 to the last two digits, so 0.7673, or we're just adding 0.0027. So 0.739. So 0.739. So the value is 0.73. This is the z value, and z value is minus a. So this is now the answer of point minus a. A is equals to minus 0.739 and a was 36 minus mu over sigma is equals to minus 0.739 and then 36 minus mu is minus 0.739 sigma. So this is number one. So in the same way, we will form another equation in mu and sigma, and then by solving them simultaneously, you can find the answers for mu and sigma. So let us come to the second condition. First, standardize z greater than 54 minus mu or sigma for standardization, and for understanding what I can let this be b is equals to 54 minus mu over sigma. Then it is probability of z greater than b is equals to 0.1. So left hand side is greater than, and for greater than we write 1 minus phi of b is equals to 0.1, and by using simple algebra phi of b is 0.9. 0.9. So again here the p is given, and z is question mark. This is z, this is z, this is z value. So p is 0.9. Coming to the table, and this table you can find 0.9, if not the number less than that, but there is another table at the bottom. So there are 9 different values, the p's and the corresponding values of z, and z and the corresponding value of p. So yes, p is 0.9, you can find here. So p was 0.9, and this 0.9 is corresponding to z equals to, so you can read it through the table, big table above, but if we have these 9 values there, specific values, then you can always write the answer directly. If p is 0.9, z is 1.282, 1.282, yes. So b is equals to 1.282, and b is 54 minus here, 54 minus mu over sigma is equals to 1.282. And again, we have another equation in mu and sigma. Next, you can solve them simultaneously. These are the 2 equations, 54 minus mu, 1.282 sigma, and 36 minus is minus 0.739 sigma. So solving simultaneously. Solving equations 1 and 2, you can find the answer. So the answer are, I've already calculated these answers. Mu is equals to, I have the answers here. Mu is equals to 42.6 in verify, and sigma is equal to 8.91. So these are the answers. These are the values of mu and sigma. So mu is equals to 42.6, correct to 3 significant figure, and the other is 8.91, correct to 3 significant figure. So this is the technique for handling the situation. Form 2 equations, simultaneous, solving simultaneously, answer is there. Find the number of, so question number 7, find the number of different arrangements of 9 letters, of the word delivered, in which 3 E's are together and D's are not together. So E's are together. Let us make a group of E's because we want to keep E's together. This is 1 unit. And other than E's, if we don't include these, the rest of the 4 letters are L, V, R, you just place in any order. E's are together. So if I ask you in how many ways you can arrange, so there are five things, 1, 2, 3, 4, 5. In how many ways, and nothing is repeated. So in how many ways you can arrange the five things? This is 5 factorial. Okay, then there are two D's. So we want to, these are not next to each other. These are not next to each other. So let us find the positions for the possible positions for D. So if D is here, so I'm just pointing out the positions out of these six positions. 1, 2, 3, 4, 5. Out of these six positions, if you place these at any two of the positions, they are separated. They are separated. So after writing E's together and LVRI, so there are five things, and these can be arranged in 5 factorial ways. And now we want to fix two D's in the spaces at two spaces of these arrows. So the two spaces out of six. So multiplied by, there are six positions, 6p2, because we want to occupy two of them out of six positions. Now, if the things which we want to separate are different, so we just leave the answer here, because as D is here, so means if one D, like if I say one D is in the start position, the other D is in the last position, and when we change the position of these two Ds, we get the same arrangement. So in order to avoid the repetition for the counting, so what you can do, you can finally divide it by 2 factorial, because of these are the same. These are the same things we want to adjust here. So 5 factorial multiply by 6p2 over 2 factorial. Yes, I can calculate. This answer is 1800. So there are 18 number of different, there are 1800 arrangements, possible arrangements. This is part 1, part A. Next is find the probability that a randomly chosen arrangements of 9 letters in the word delivered has exactly 4 letters between two D's. So for this, we need to find the total number of arrangements, because the probability we write denominator, total possible outcomes. So let us write, first of all, total number of arrangements. Total number of arrangements is equals to 9 factorial divided by, there are 3 E's, 3 factorial, there are 2 D's, 2 factorial. So this answer is 3, 0, 2, 4, 0. So these are total number of arrangements. Find the probability that randomly chosen arrangements of 9 letters in the word has exactly 4 between two D's. 4 letters between two D's. So for this, I can make a plan. I can do the planning like this, that 2 D's and exactly 4 in between. So what I can write D first, then I can leave 4 spaces in between, and then another D. So in other words, so this is one block in which we have D and a D, and there are exactly 4 in between. And other than these 4, because 9 minus 2, there are 7 left. So 4 we have adjusted in between, and there are 3 left. So 1, 2, 3. So the point is that we want to make arrangements in which there are exactly 4 letters between two D's. So D and D. So I made a group for D's and 4 letters in between. And now for this concept, what I can do, I can make one of the arrangements. Say we have L here, we have V here, we have R here, and we have I here, and say E is here, say E is here, say E is here. So E can be in between, any one. All the three can be in between the two Ds, or any one or two or all threes at any position. So just this is one of the arrangements. So here, as these are fixed, and there are seven letters other than these, and in those seven letters, E is there three times. So number of arrangements you can identify this way as the number of arrangements, number of arrangements, number of arrangements. So these we have fixed, and they are seven. You can write 7 factorial divided by an E three times there, so divide by 3 factorial. So this is not enough, right? Just only 7 factorial, 3 factorial. No, the point is that the this block in which there are exactly 3 or 4 letters in between, this block can be at any position. So here I kept this on the extreme right position. It can be extreme left position. It can be, this block can be here. This block can be here. This can be after 2, and this can be on the. There are 4 possible positions for this block to appear. So what I can do in the end, after writing 7 factorial, this is the basic thing, multiply by 4, because there are 4 possible positions for this block, not factorial, just 4. There are 4 positions. And when you simplify, it is 7 factorial, 7 factorial, 1 divided by 4 divided by 6. So 3360. 3360. P360. So these were the total number of arrangements if there is no any condition on the 9 letters of the word delivered, and this is the required satisfying the given condition. So the required probability is, so the required probability is divided total number of the favorable outcomes 3360 over total number of outcomes 30240. So 240, because probability के लिए we need favorable outcomes satisfying the condition in the numerator and total number of outcomes in the denominator, and so the answer is 1/9 is the required probability. So the probability of this is 1/9 is the answer. Okay, now I think it's clear. The last is, yes, 5 letters are, the 5 letters are selected from selected. So selected means this is part of the concept combination. 5 letters are selected from 9 letters that were delivered. Find the number of different selections of 5 letters. In letters include at least 1 D, at least 1 E, at least 1 D. So there are 2 methods. You can involve a permutation combination directly, or you can use the factorial concept, or you can list first and then you can count. So as there are only we are talking about 5 letters, so it's better to list. So there are listing different things here. Not all the possibilities I can list, but I can just make an idea. One possibility is that there is 1 D and 1 E. So other than D and E, there are L, I, V, R. There are 4 things. So if there are 2 and I want to make 4, so out of 4, we need 3 more. Sorry, out of 4, we need 3 more in order to make a selection of 5. So this answer is 4. With 1 D, there can be 2 E's. So we have selected 3 of them. Then from the rest, L, I, V, R, we need 2 more. So this answer is 6. If it is D, and then yes, there are 3 E's, it can be with 3 E's. So this is selection containing 1 D and 3 E's. So we need 1 more now to complete selection of 5. So we need 1 more. So this answer is coming as 4. Okay. After D's, you can start with single D with 2 D's options. D and D with E. So 3 we have selected, we need 2 more. 6 is the answer for 4C2. Again, it can be 2 D's and 2 E's. So we have selected 4 of them, we need 1 more. So in order to complete a selection of 5, this answer is again 4. No. Then I think the last option is 2 D's and 3 E's. So already we have selected everything. So from the rest of L, I, V, R, we need nothing. So answer is 1. So just count them. These are different options. So I'm not writing all the options, but just I'm getting the idea. It can be with 1 D and 1 E, 1 D and 2 E's, 1 D and 3 E's, and then 2 D's, 1 E. So it's simple. You can keep a record of this. And then after writing that out of the remaining 4, we need 3, sometimes we 2, sometimes we 1, because it depends upon the how many things which we have selected already there. So answer is 24 and 25. 25 is the answer for this part, the number of selections, number of different selections. So required number of selections is 25, the answer. Thank you very much.